Go to where it says results. And there you can open it. When you guys are in your homework and try to click on it and it doesn't let you in, because it thinks you're trying to get into it to redo it. Go to results, and throughout the entire year, everything that you've ever had should be inside those results. And you'll be able to access it and deal with it that way. You guys in this row, if this gets in your way, you can slide your desk over, or you can sit in this row. Doesn't matter. Here it says use the number line below where RS is 7y plus 3, ST is 2y plus 4, and RT equals 13y minus 13. Okay? What's the value of y? And then find those three segments independently. What you got to realize here, and I've been working with several people who keep doing this, is that they just want to say, well, the last thing is always what I'm equal to. You can't do it that way. Okay? You have to look at your picture and you have to realize that they are not giving me these in order in regards to, like, I want to take RS and ST and add those together, and it's always going to give me R to T. Does that make sense? In this case, it does, but there will be questions that you see in your homework tonight where they flip-flop these in any order. So you can't just say first two things add up to give you the last thing. Does that make sense? Or maybe one of these will be where that's always a number, like 104. Okay? And somebody was saying, I'm going to take this one, the ones that are have expressions in them, and add them together so I'm equal to anything that has the number. You can't do that. You have to use the picture in conjunction with the information that they had in regards to what these distances are to set up the appropriate relationship. So what they're saying here is R to S. So that distance, I don't know why they make the number line so big, but that distance there is 7y plus 3. And then they say S to T is 2y plus 4. Okay? Basically, with the segment addition postulate, what we're looking for is a series of consecutive segments that are end to end that take me from the beginning of a segment all the way to the end. So do those two, the red segment and the blue segment, do they do that? Yeah. They give me from the beginning to the end. So we're going to add those together. We're going to add the red one, so 7y plus 3. We're going to add that to the blue one, which is going to be 2y plus 4. So plus 2y plus 4. Those are the two things that we're going to sum together. Gets me from R all the way to T. But I got to have that equal to something. Would you agree that R to S and then S to T, add those together, is the same thing as if I would have started at R and traveled straight through T?
Yeah.
Yeah. And that expression they're saying is 13y minus 13. Alright? So we're seeing there that two individual smaller parts combined together through addition should give me the total. And now all we got to do is we got to go through, and I get what, 9y plus 7 is equal to 13y minus 13. I'm going to add 13 to both sides and subtract 9 from both sides. So it'll give me 4y is equal to 20, so what's y got to be? Say again? 5. Y's got to be 5. Alright, so be careful when you plug your answers into this stuff, and we talked about this in pretty much every class today, but notice it tells me some basically hints here, right? If I would have found an answer as like 10 over 2, or if I would have left it as 20 over 4, it's not going to accept that because 20 over 4 is neither an integer or a decimal. Does that make sense? 20 over 4 needs to be rewritten as 5 as an integer. Okay? And that becomes very important as you start to do some questions, because a lot of times this information here will tell you or lead you to an understanding of whether you've done things right or not. Say I go through all my work and I find y. Let's just say it says type an integer. That's all it says. And I find y to be 21.2. What's that tell me?
Keep it in the form before. Keep it in fraction form.
Well, is fraction form an integer?
No.
No, integers are just 0, 1, 2, 3, 4, 5, 6, 7, and their opposites. Okay, all the way to positive and negative infinity. So 21.2 is not an integer. So what's that tell me about my work? I've probably done it wrong. Because thinking about how they've written this, they've already done the problem, right? They already know what the answers are supposed to look like. And they're saying your answers are supposed to be integer format. And if you found something that's not that, you know you've done something wrong. Okay? Well, that's nice. Like an ACT doesn't do that. Okay? An ACT might give you a couple integer results, a couple decimal results, a couple fraction results. But this is kind of nice. You can read into that and say, okay, I know maybe before I even do the problem, I'm going to get one or two of the, maybe an integer, or I might get a decimal, or it says type as a fraction, and say, okay, I'm not even going to deal with decimals now. I'm just going to solely work with just my fractions. So that those things right there, people overlook them. Okay, the things that people overlook are the directions and the hints. Okay, or the methods that they want you to take your answers into. Those are some of the most important things to look at when you're doing these problems. Does that help?
Yeah.
Good.
I got the answer. Except I can't take away from this late.
It's late. Okay.
Wait, so what do we do for at home? We have a question about that.
Research it.
Can't do a question on it.
Research it.
Look at his YouTube channel.
You can look at my YouTube. You can look at the videos that I post on the website, because I'm trying to teach you that at some point in your life you're going to be in a course where you don't have an opportunity to answer questions and you don't have everything at your fingertips. Okay, and you've got to do some work on your own. You got to do some digging to find out what you need. Now, my website is structured because you could legitimately search the entire internet, right? Which is huge. All right, it'd be very time consuming. My website has taken the things from the internet and kind of narrowed your vision down, and there's only 5 or 6 maybe videos that you would have to search through instead of maybe 500 or 600. So I've already done a lot of the searching for you. Now you just got to go a little bit further. Yep. Number 20.
So wait, one more time.
Yes, ma'am.
How many questions? 50.
Just 12. That's not hard. All right, so this question is an example of where people get into a habit of saying, we did angle addition, angle addition, angle addition, angle addition. We get to this question, and we look at it, and we see, oh, we got 3 angles here. Would you guys agree? We got that red angle, we've got that green angle, and that blue angle, right? So people say, well, the red one is that one, green one is that one, blue one is that one, right? So we start adding those together, correct? Because that's the habit we've gotten into. When we start adding those together, when you add them together in angle addition or even segment addition, you always need a what to set them equal to? What do we have in the last one? We have a total, didn't we? You always need that total. Do we have anywhere here, do they give me a total for angle AOD? No. Okay? So even though you might start blindly approaching this problem and setting it up and start adding things, you get to kind of a roadblock and say, well, I don't know what to set it equal to. Okay? I don't have that total. So that's not the approach that we want to use here. It's a little bit different. And we look at this, and it's not all that insightful. But if I look at those 2 markings inside those angles, those 2 little arcs tell me that those 2 angles are what to one another? Equal. Okay? The shapes are congruent, and then the measurements are equal. Okay? So that tells me that that measurement there and that measurement there have to be identical. So we're going to say 6x minus 5 is the same thing as 3x plus 16. Okay? That's an x. So 3x plus 16. And now we just go through and solve it like normal, right? Subtract 3x from both sides, so we get that, add 5 to both sides, we get that. X in is 7, so put a 7 there. And now that each one of these, even though we didn't use this one, BOC, we didn't use that in the expression, it's still using the exact same x, right? So we can actually go and find that value. 7 times 6 is what, 35 minus 5 is 30? What's this one going to be? That did it wrong. 7 times 6 is 42. 42 minus 5 is 35, right?
Yeah.
Okay. No, messed that up again. 42 minus 5, 37. I make mistakes. 3 times 7 is 21 plus 16, 37 again, right? And that should have been true, right?
Yeah.
Okay, that's what we set up here. It said those are equal. Okay. Now if I plug in 7 here, 2 times 7 is 14. 14 plus 12, 26. Okay. Would that allow me, once I know those three, would that allow me to find maybe that angle measurement right there, AOD, which would have been the total that we were not told at the beginning. Okay. But it's all about looking at notation, and that's kind of the learning curve that exists inside this course, and really any math course really early on, is that you start learning notation stuff. Mrs. Coles was talking today about how she has to explain to her algebra students, and she probably did this to you, a long time ago we did, like, 2nd grade, 3rd grade, 2 times 3 looked like that, right? Okay, well then we started to do more things, and it became a little bit better to do 2 times 3 like that, right? And now she's explaining to her students that we don't do that anymore. We don't use those anymore. Because eventually we're going to start using x as a variable, right? So now we do that, right? So to imply multiplication. So there's always notation things you got to talk about in a course. And those markings in that set of angles is that notation concept. What MathXL usually does is to draw your attention to them. They will color code them. So here they're both red. You'll see a variety of different ways that they do that. They'll say, let's say we've got a different picture here where we've got maybe all of those angles. Let's say that one is congruent to that one, but then we want this one here to be congruent to that one, but not all 4 of them to be the same. So to differentiate, they'll do that. They'll put 2 different arcs in there. Is that all right? Sometimes instead of the arcs, sometimes they'll do this. They'll say, they'll put an arc in everything. They'll put a slash through that one, a slash through that one, and then they'll put 2 in that one, 2 in that one. That's what I most commonly do. That's what I'm familiar with when I was taught that way, so it's hard to break that habit and do it a different way. So you'll see me do that too. Okay. Does that make sense? All right. And that's hopefully once you guys recognize that, that's what you need to look at. The algebra part's not that hard, right? It's the notation and the geometry. All right. Anything else? Any other questions? Problems we want to go over? Nothing else?
Nope.
We're good on everything else. Might be too late tomorrow to ask questions.
Oh, wait. I remember. I don't have a question.